Your Toyota's air conditioning is almost certainly capable of blowing 10 to 20 degrees colder than it does right now, and getting it there costs about $40, takes one morning in the driveway, and never once involves opening up the refrigerant system. That is the whole deal. 4 jobs, none of them difficult, all of them things a shop would rather sell you than teach you. Let me deal with the title honestly before we go a step further, because I would rather you trust me at minute 25 than be impressed at minute 1. Cold is not a quantity. You cannot double it. What you can double, and what I have doubled on cars sitting right in front of me, is the temperature drop across the system. The difference between the air going in and the air coming out. On a healthy setup, that drop is somewhere around 30 to 40 degrees. On a neglected one, it collapses to 12 or 15, and the owner swears the refrigerant is low. Take that 15 back up to 35, and yes, in every way that matters to the person sweating in the driver's seat, the air conditioning got twice as cold. Nothing was recharged. Nothing was replaced but a filter. I have had the front bumper cover off enough Toyotas to know exactly what lives in the bottom third of the condenser, and it is never what people expect. Not dust. Compacted vegetable matter, insects, and a layer of oily road film that has been baked on and rained on and baked on again for 8 summers until it has the texture of felt. Here is where we are going. Stage 1 is a measurement, and I am going to ask you to do it before you touch anything, because without it, you are guessing. Stage 2 is the cabin filter, and there is one detail about putting the new one in that half the people reading the box get backwards. Stage 3 is the condenser, which is where most of your missing cold went. Then a 60-second test with the hood up that explains completely why your air conditioning is perfectly fine at highway speed and useless in a drive-through line. And at the very end, the aerosol can sitting on the shelf at every parts store in America that can get your vehicle politely refused by every reputable shop in your town. I will tell you exactly why and what the shop's machine has to do with it. There is also a setting on a lot of these vehicles that deliberately limits how hard the air conditioning is allowed to work. Not a fault. A designed behavior documented in Toyota's own owner's manual, which even tells you to switch it off if you want better cooling. Almost nobody who owns one of these cars knows it exists. We will get to that, and I will show you the page it lives on. Start with what the system actually does, because if you have the wrong model in your head, every symptom points you at the wrong part. Your air conditioning does not make cold. There is no cold in there. It is a heat pump, and its entire job is to pick up heat from inside the cabin and carry it outside and throw it away. The refrigerant is the bucket. It gets sprayed through a metering valve into the evaporator core buried in your dash, where it flashes from liquid to vapor and gets extremely cold doing it. Your blower fan pushes cabin air across that cold core. The air gives up its heat and most of its moisture, and that is the air arriving at your face. The now warm vapor goes to the compressor, gets squeezed hot, and heads out to the condenser at the very front of the car, ahead of the radiator, where outside air blowing through it strips that heat back out and the refrigerant turns liquid again. Then round it goes. The bucket only works if you can empty it. That is the whole thing. Everything I am about to have you do is about making sure air can get through the 2 heat exchangers, the one out front that dumps heat, and the one in your dash that collects it. Choke either one and the system does not fail, it just quietly gets worse A couple of degrees a year, so slowly that you adapt to it. Nobody notices their air conditioning getting weaker. They notice one July afternoon that it is not cold anymore, and assume something broke last week. Two of the three things that make cold air are airflow, and airflow is free. The third is refrigerant charge, and that is the only one that costs money and requires equipment. Guess which one gets sold first? Before we start, the honest rundown on what you need and whether this is your job at all. A digital probe thermometer, $10 or $12. The kind sold for cooking meat is perfect, and I am not joking. A cabin air filter for your specific model and year, $15 to $40 depending on whether you want plain paper or activated carbon. A can of condenser coil cleaner from the parts store or the home center. By the way, if you drive a Toyota and want to keep it running for hundreds of thousands of miles, what you do before something breaks matters far more than most owners realize. That's why I put together the 500K Mile Car Care Bible. It covers 101 habits that can help your Toyota last longer, the warning signs you should never ignore, and how to spot mechanic upsells that quietly drain your wallet. To get your copy, just scan the QR code on screen with your phone's camera, or grab it from the first pinned comment below. A garden hose with a normal nozzle, a soft brush, a plastic trim tool, though a butter knife wrapped in tape has gotten me out of trouble more than once. Call it $40 to $60 all in, plus a couple of hours if you take your time. When to hand it over instead: if you can see oily, wet residue around any fitting or on the compressor, you have a refrigerant leak and cleaning will not fix it. If the compressor makes a grinding or rattling noise when it engages, stop and get it diagnosed before you spend money on anything else. And if somebody has already put a sealant can into the system, everything downstream of that changes, which I will explain when we get there. Stage 1. Measure it. Do not skip this, and do not do it casually, because this measurement is the difference between knowing you fixed something and hoping you did. Park somewhere out of direct sun, get the engine to full operating temperature, set the climate control to the coldest setting, blower on medium-high, recirculation on, all the doors and windows shut. Push the thermometer probe into the center dash vent so it sits well inside, not at the lip. Then leave it alone for a solid 10 minutes and hold the engine around 1500 RPM for part of that. Or better yet, drive it, because at idle, the condenser gets much less air and the reading will be pessimistic. Write down two numbers, what the vent says and what the outside air says. Humidity too, roughly, because a swampy day genuinely costs you a few degrees, and it is not the car's fault. Now, what is a good number? Sources genuinely disagree here, and I want to be straight with you about that. Some shop references want 35 to 40 degrees below ambient. Others say 30. Others skip the subtraction entirely and give you an absolute figure, something in the high 30s to around 50 at the center vent with the system on max and recirculating. I take the conservative one. If you are getting a 30-degree drop below outside air, your system is working. 20 to 30, it is soft, and there is real money on the table. Under 20, something is wrong, and it is very probably something on this list. One thing that reading cannot tell you is which of the three failures you have, and anyone who says otherwise is selling. A restricted condenser, a plugged cabin filter, and a genuinely low charge can all produce the same lukewarm number. That is precisely why we do the free work first and measure again. Stage 2. The cabin filter. This is the smallest job on the list, and it is the one that most often produces a visible jump, because a filter that has been in there 4 years is not filtering anything. It is a wall. On virtually every modern Toyota, it lives behind the glove box. Empty the box out first. Open it all the way and look along the right-hand side with a flashlight for the little damper arm, the small strap that keeps the door from flopping open. Pop that off its peg, gently, because that clip snaps if you get impatient with it. Then squeeze both sides of the glove box inward to clear the stops and let it swing down. Behind it, there is a rectangular plastic cover with tabs. Press the tabs, pull the cover, slide the filter straight out. Keep it level coming out. I mean it. 4 years of leaf litter is sitting on top of that filter, and if you tip it, all of that goes straight down into the housing, past the point of filtration, and lands on your evaporator core, which is the one part of this system you genuinely cannot get to without pulling the dash apart. I have seen shops create a $1,400 problem in 10 seconds doing exactly that. Now the detail people get wrong. The new filter has an arrow printed on the frame, and the arrow means airflow direction, not which way is up. The housing may also be stamped with the word UP, and those two instructions can appear to contradict each other. Follow the arrow. In these cars, air comes in high, near the base of the windshield, and travels down through the filter to the blower, so the arrow points down. If you are unsure, look at the old one you just pulled. The dirty side is the side the air arrived from. Put it in backwards, and you have not created a disaster, but you have restricted flow, made the blower work harder. And if it is a carbon filter, you have largely wasted the carbon layer, because the odor-absorbing side is now facing the wrong way. Toyota's schedules generally have you replacing this around every 15,000 miles, and the manual itself notes that heavy traffic, dust, and dirt roads shorten that considerably. The part costs $15 to $40. RepairPal puts the average shop charge for this job somewhere in the $90 to $113 range, and dealers commonly sit above that because of labor minimums. The work takes 10 minutes. I am not saying nobody should ever pay for it. Some people simply do not want to lie sideways in a footwell, and that is a perfectly respectable position. I am saying you should know what you are buying. While the cover is off, put your flashlight into the empty housing and pull out whatever is in there by hand. There is always something. Stage 3. The condenser. This is the big one. This is where most of your missing cold is, and it is the job nobody does. The condenser is that thin aluminum panel of fins mounted right at the very front of the car, ahead of the radiator, directly behind the grill. It is the first thing every bug, seed, leaf, and piece of road grit meets at 70 miles an hour, and it has been catching all of it since the day the car was new. Debris packs into the lower third first. That is nearly universal, and it is where you should look before anything else. On truck-based Toyotas with a skid plate, you often cannot even see it until the plate comes off, which is a large part of why this goes unnoticed for a decade. Here is the mechanism, plainly. The refrigerant arrives there as a hot, high-pressure gas, and it has to give up enough heat to condense into a liquid before it reaches the metering valve. If it does not fully condense, the valve is trying to spray liquid and is getting a froth of liquid and gas instead. The evaporator does not get properly fed, and your vent temperature climbs. Meanwhile, head pressure goes up, the compressor works harder, and you burn fuel doing it. Restricted condenser airflow raises high side pressure. That is not a theory. That is the first thing a technician looks for when the gauges read high and the vents read warm. The clean. Get the grill off if it comes off easily on your model, or work from the engine side if that gets you better access. Bag or towel anything electrical you can see. battery terminals, alternator, exposed connectors. Dilute your coil cleaner per the label, coat the fins, and give it 10 minutes to work. Then rinse with a garden hose at ordinary household pressure, ideally from the engine side outward, so you are pushing the debris back out the way it came in rather than driving it deeper. Do not use a pressure washer. I know it is tempting and I know it looks satisfying on video. Those fins are thinner than a business card and a pressure washer will fold them flat or split a tube. And now you are shopping for a condenser, which on a Camry or a Corolla runs roughly $800 to $1,000 installed. A 50-cent fin comb straightens the ones that are already bent. If the aluminum is powdery and white and the fins crumble when you brush them, that is salt belt corrosion, and cleaning will not save it. I will not pretend I can tell you the exact number of degrees this buys you, because nobody publishes a controlled figure for your specific vehicle, and I am not going to invent one. What I can tell you is what I have watched happen with a thermometer in the vent. On badly plugged ones, most of the gap closes, and the compressor stops running as long a cycle to hold the same cabin temperature. Owners on the Toyota forums describe the same thing after a coil cleaner and hose treatment, including on cars only 2 or 3 years old with under 20,000 miles. That last part surprises people. It should not. Mileage is not what fills a condenser. Miles at speed on a road with a shoulder full of dry grass in August is what fills a condenser. You are still with me, which means you are the sort of person who does the boring stage properly. So here is the thing I would want somebody to tell me. If you take one action from all of this, make it the condenser. The filter is easier and it feels more productive because you can hold the dirty thing in your hand. The condenser is where the cold actually went. Quick pause. If this is doing what I hoped it would do, giving you something you can actually go and use rather than a list of symptoms, subscribing keeps it coming. And that is the whole ask. Now let me pay off the fan test I flagged at the start because it is 60 seconds and it explains a very specific complaint. Stage 4. The fan check. Pop the hood, start the engine, turn the air conditioning on, and watch the fan behind the radiator. It should spin up, and in most cases it should come on within seconds of the compressor engaging, whether or not the engine is anywhere near hot. That fan is not primarily there for the engine. It is there because at low road speed there is no air moving through the condenser at all, and without it, you have a heat exchanger with nothing to exchange with. That is your drive-through symptom. Ice cold at 50 miles an hour, useless the moment you stop moving. If that describes your car, the fan is the first place to look. A failed motor, a bad relay, a fuse. It is a comparatively cheap fix, and it gets misdiagnosed as low refrigerant constantly, because to somebody who is not looking under the hood, the two feel identical. Stage 5. The settings. And this is where the free performance lives. Recirculation. When you pull the outside air position, you are asking the system to take 100-degree air and cool it down all over again, every second, forever. On recirculation, you are recooling air that is already cooled. This is not folk wisdom. The National Renewable Energy Laboratory has modeled exactly this, and their conclusion is blunt. After cutting solar gain, the next most effective way to reduce air conditioning load is to reduce how much outside air you are conditioning. A peer-reviewed cabin study found that pushing recirculation up around 90% in a warm climate cut climate control power by about 12%, while also dropping in-cabin fine particulate by a large margin, because the filter gets to work the same air over and over instead of drinking from the road. The caveat, and it is a real one: recirculate for too long with people in the car and carbon dioxide climbs and the glass fogs. So run recirculation to pull the cabin down, then let some fresh air in. It is not an all-day setting. Blower speed. Counterintuitive one. A lower blower speed usually gives you a colder reading at the vent because the air spends longer in contact with the evaporator core. A high blower speed moves more total heat out of the cabin, but each cubic foot of it is a couple of degrees warmer. So blast it while you are purging the hot air, then back it off once you are comfortable. Do not chase the thermometer number at the cost of actually cooling the car. And before all of that, get the hot air out. A cabin that has been soaking in the sun is not 100 degrees. It is far hotter than that at the dash. And the NREL work on windshield shades found a reflective shade knocked the instrument panel temperature down by an enormous margin, around 25 degrees Celsius in their measurements, even though the air at head height only came down a few degrees. That hot dashboard is a radiator pointed at you all afternoon. Windows down for 30 seconds, or the doors open, then close it up and go to recirculation. Stage 6 is the short one. Once every few weeks, before you shut the car off, switch the compressor off and run the blower on fresh air for a minute or two. That dries the evaporator core. A permanently damp evaporator in a dark plastic box is where the musty smell comes from. And once that colony is established, it is genuinely difficult to get out without dismantling the dash. Cheapest maintenance on this entire list. Costs you a minute. Stage 7. Refrigerant, and when it is actually the answer. If you have done everything above, measured again, and the drop is still under 20 degrees, then yes, you may genuinely be low on charge. But understand what low means here. A modern system is charged by weight, to a figure printed on a sticker under your hood, and these systems are unforgiving about it. A few ounces off in either direction measurably hurts cooling. Undercharged, the evaporator is starved and the vents wander warm. Overcharged, the condenser cannot condense properly. Head pressure climbs, and the vents also go warm. Same symptom, opposite cause. That is why guessing off a low side gauge on a hot afternoon is close to worthless. The only honest procedure is recover what is in there, weigh it, evacuate, and put back exactly what the label says. And a system does not consume refrigerant. It is a sealed loop. If it is low, it leaked, and it will leak again. A recharge without a leak search is a rental, not a repair. Now the can. Walk into any parts store, and there is a colorful aerosol on the shelf promising to recharge your air conditioning for $35. Most of the kits, not all, but most, so read the label, contain a stop leak additive mixed into the refrigerant. Those additives are moisture activated. Inside a properly sealed system, there is no moisture, so nothing happens, but your system is low, which means it has a leak, which means atmospheric humidity has already got in. So the sealant meets the moisture and cures into a hard, gummy residue that then circulates through the loop and takes up residence in the narrowest passage it can find, which is your metering valve. Once it has set in there, no flush dissolves it. That component is finished. And here is the part almost nobody sees coming. Professional shops run a refrigerant identifier on your service ports before they connect their recovery machine. And if it flags an additive, a great many of them will simply decline the job. Not out of spite, but because sealant destroys the valves inside a recovery machine that costs them thousands of dollars. So the $35 can end with you owning both a ruined expansion valve and a car nobody local wants to touch. I am not neutral on this, and I am not going to pretend to be. Time to verify. Repeat the measurement from stage 1. Same conditions, same 10 minutes, same vent, and compare. If you were at 18 degrees of drop and you are now at 32, you are done, and you just saved yourself a repair bill. If it barely moved, you now know something the shop does not. Airflow is not your problem, so nobody needs to sell you a filter and a cleaning. Now the part that annoys me. There is a mode on a great many of these vehicles called Eco Air Conditioning. On some, it is a button on the climate panel with a small green light. On others, it rides along with the drive mode. And Toyota's own owner's manual states plainly what it does. In Eco Air Conditioning mode, heater and compressor operation are controlled to restrict heating and cooling capacity, and fan speed is restricted in automatic mode. The manual then tells you, in the same section, that to improve air conditioning performance, you should turn Eco Air Conditioning mode off. Read that again, because it is remarkable. The document that came in your glove box contains a paragraph explaining that your air conditioning has been deliberately limited, and a second paragraph explaining how to unlimit it. It is on page 393 of one manual, page 419 of another. Deep in the back, in a wall of small type, in a section most owners open exactly once in the life of the car, when they are trying to work out which fuse controls the cigarette lighter, and there is a second half. In the same passage, the manual notes that above 75 degrees outside with the air conditioning on, the system may switch itself to recirculated air automatically to reduce power consumption, and that recirculation is the default when you turn the car on. So the system will make that choice for you, silently, either way, based on what saves fuel rather than what makes you comfortable. Owners on the RAV4 forums report exactly what you would expect from reading the manual. Switch Eco off on a 90-degree day, and the air gets colder immediately. I want to be careful and fair here. This is not a defect, and Toyota is not hiding anything illegal. It is documented. The behavior varies by model and by year, and I have not personally verified it on every single one. So check your own manual rather than take my word for your specific car. And the engineering logic is completely defensible. The compressor is a parasite on the engine, restricting it saves measurable fuel, and fuel economy figures are how cars get sold and how corporate averages get met. But notice who was never asked. You bought the vehicle. You are the one sitting in it in August. And the decision about whether your comfort or a fractional fuel economy gain matters more was made in a meeting years before you saw the car, encoded into a default and communicated to you by way of a small illuminated symbol and a paragraph on page 393. Nobody at the dealership walked you out to the car and said, "By the way, this button makes it colder." Nobody puts it in an advertisement. There is no reason they would. It is not a feature that helps sell anything. That is the whole shape of it. And it is not a conspiracy. It is just an incentive pointing away from you. The people who chose the default are optimizing a number that is measured at the factory. You are optimizing a number measured on your face at a red light. Those are different numbers, and when they conflict, the default goes to whoever was in the room. So push the button. It costs you nothing. It is reversible, and it is yours to decide. Let me put the whole thing back together in order. Measure first, always, with a probe thermometer in the center vent, engine warm, max cold, recirculation on, 10 minutes to settle, and write down the outside temperature next to it. Second, the cabin filter. Behind the glove box, damper arm off, side squeezed in, cover tabs pressed, filter out level, New one in with the airflow arrow pointing down, and clean the housing out while you are in there. Third, the condenser, coil cleaner, 10 minutes to dwell, garden hose pressure only, rinse from the engine side outward, fin comb for the bent ones, and never a pressure washer. Fourth, hood up, engine running, air conditioning on, confirm the fan spins. Fifth, the settings, eco off, recirculation on. Once you have purged the hot air, blower back down after the initial blast, and a reflective shade in the windshield when it is parked. Sixth, dry the evaporator with a minute of blower only before shutdown. Then measure again. And here is the procedure that replaces guessing, which is the bit I actually want you to keep. Do not ask yourself whether the air conditioning feels weak. Feelings are useless here. You adapt to a slow decline. Instead, run the numbers. If your post-cleaning drop is 30 degrees or better, spend nothing. The system is healthy. 20 to 30, retest on a cooler, drier morning before you commit, because humidity alone moves that figure several degrees. Under 20 after everything above is done, then pay for a proper diagnosis. And when you do, ask for one specific thing in writing. The weight of refrigerant they recovered out of your system compared against the weight on your underhood label. That single number tells you whether you had a leak, whether somebody previously overcharged it, or whether the charge was correct all along, and the fault is somewhere else entirely. A shop that will happily give you that number is a shop worth going back to. The payoff is a bill that never arrives. The condenser on a Camry runs somewhere around $860 to $1,000 installed. A compressor on a Corolla lands around $1,000 to $1,500. And if a compressor lets go internally and puts metal through the loop, you are looking at replacing most of the system, which is commonly quoted between $1,500 and $3,000. None of those quotes are coming your way this summer, because a starved, overworked system is a system running high head pressure with a compressor grinding away at it, and you just took that load off. You will never see the invoice you avoided. That is the frustrating thing about maintenance, and it is also the entire point of it. Tell me where you are watching from, and what the weather actually does there, because this subject is more regional than almost anything else I cover. Cottonwood country and coastal salt air and Arizona dust and Gulf humidity all wreck an air conditioning system in completely different ways and on completely different timescales. And the comments on a video like this end up more useful than the video. If you clean a condenser twice a year because of where you live, say so and say why. And if you do this work for a living and I have got something wrong, particularly on the newer variable displacement compressors, where the control strategy is genuinely different from the old clutch cycling systems, and where I will freely admit my instincts are still calibrated to older hardware, come and correct me. I read them, and I would rather be corrected in public than confidently wrong in private. There is one thread here I deliberately did not pull, and it has been bothering me for a while. That evaporator core, sitting damp in the dark behind your dash, is doing something to the air you breathe every day, and the industry's answer to the smell it produces is a can of scented spray you fire into the vents. I do not think that is an answer. I think it is a deodorant applied to a biology problem, and I want to find out what actually works before I say anything more about it. So I am going to go do that. Go measure yours. 10 minutes, a cheap thermometer, and write the number down. Because whatever happens next, you will know instead of guessing. And that is worth more than any part you could bolt on.